In this video, we're taking a look at whether or not a sequence is geometric and then writing a recursive definition for the sequence. Let's take a look at our first question. So here we have the sequence, and the first thing we want to do is to find the ratio between the consecutive terms. Now, in order to find the ratio between the consecutive terms, we'll be dividing them. So dividing 2.8 by 1.4, we get 2. Next, dividing 3.36 by 2.8, we get 1.2. Lastly, we are dividing 5.04 by 3.36. And for that, we're getting 1.5. Notice here that the ratio between the consecutive terms is not constant. Now, because the ratio between the consecutive terms is not constant, we know that this sequence is not a geometric sequence. Now, let's take a look at another question. Now, just like before, in order to find the ratio between the consecutive terms, we'll be dividing the consecutive terms. 0.6 divided by negative 1.2 gives a ratio of negative 0.5. Negative 0.3 divided by 0.6 gives a ratio of negative 0.5. And lastly, 0.15 divided by negative 0.3 gives a ratio of negative 0.5. Now, because the ratio between the consecutive terms is constant, we know that this is a geometric sequence. Given that this sequence is a geometric sequence, we can write the recursive definition for this sequence. So for this sequence, we just found out that the common ratio is negative 0.5. Taking a look at the sequence, we can tell that the first term is negative 1.2. So the recursive definition here is A sub n is equal to our first term, which is negative 1.2, if n is equal to 1. And the rule for the nth term is our common ratio, which is negative 0.5, times the previous term. The previous term is represented by A sub n minus 1, or A subscript n minus 1, if n is a whole number greater than 1.